Welcome back. We usually stick to more immediate concerns, but today we're looking way, way ahead.
Way ahead, yes, to the ultimate fate of the universe itself.
And we're drawing on some fascinating NASA research highlighted over at ecoticious.com. It points towards something called the Big Freeze.
That's right, the Big Freeze. It's a theory increasingly supported by evidence, like data from NASA's WMAP probe.
WMAP, right? Wilkinson Microwave Anisotropy Probe.
Exactly. And it suggests the universe is heading towards what scientists sometimes call heat death, basically cooling down indefinitely.
Heat death. Sounds pretty final, and this is because it just keeps expanding.
Precisely. Relentless expansion, driven by something called dark energy. It's this, well, this mysterious cosmic force.
Okay, dark energy. Let's unpack that. So the universe expands, it gets colder. Is it like stretching something out until it's thin and cold?
That's a decent analogy, yeah. This dark energy, it kind of regulates the expansion rate. It actually accelerates the separation of galaxies.
Accelerates the separation, so they're moving away from each other faster and faster.
Exactly. While the overall, speed limit of expansion might be complex, the distance between galaxies grows at an accelerating pace.
Oh, okay, got it.
And the consequence, yeah, a gradual, steady drop in temperature across the cosmos,
Leading to.
leading eventually to a point where there's just not enough energy for stars to form or even, keep shining.
Wow, just fading out. A cosmic void, essentially.
That's the picture the Big Freeze paints, yes.
Yeah.
A vast, cold, dark void, no new stars, and eventually all existing ones extinguished.
That is quite a concept to wrap your head around. This dark energy, then, this sort of anti-gravity force. How did scientists even figure out it existed?
Well, it was back in the 1990s. Astronomers were looking at really distant supernovae, exploding stars, basically.
Right, standard candles.
Exactly. They expected to see the expansion slowing down due to gravity pulling everything back together.
But they didn't.
No, they saw the opposite. The expansion was actually speeding up, accelerating.
Whoa, so something had to be pushing things apart.
Precisely, something counteracting gravity. That's where the idea of dark energy came from, this component with negative pressure forcing things apart.
And it's not just some minor effect, is it? I read it's a huge part of the universe.
Huge is right.
Yeah.
Get this. Current measurements suggest dark energy makes up about 71% of the total energy density of the universe.
71%. That's almost three-quarters.
Yeah, it dominates. It's the primary driver of how the universe is evolving now and likely how it will end.
So this constant push means galaxies just drift further and further, more isolation.
That's the implication. Over billions and billions of years, the vast distances mean light from faraway objects gets fainter, redshifted, eventually undetectable.
So looking up at the night sky in the far future, it would be much darker.
Incredibly dark. Galaxies would become these isolated islands, effectively cut off from each other in an ever-expanding, darkening sea of space.
And what about the galaxies themselves? Do they stay intact forever?
The theory suggests not. Even within galaxies, things change. Star formation requires gas clouds density. That fuel runs out.
So no new stars are born.
Eventually, yes. And the existing stars, well, they have finite lifespans. They'll burn out. White dwarfs, neutron stars, black holes.
Leaving behind just remnants.
Cold, scattered fragments. The universe transforming into this sort of frozen, dispersed state. The dynamic systems we see now, gone.
It's humbling. The Ecoticious piece mentioned this highlights the uncertainty of the duration of everything that exists. Makes sense.
It really does. It challenges our, perhaps, default assumption that things, even cosmic structures, last forever. They have lifespans, just on scales we can barely comprehend.
So thinking about this cosmic end,
Right.
does it give us a different perspective on, well, now?
I think it can, yes. Contemplating this deep future, this eventual cold quietness, it can maybe encourage us to, appreciate the current era, this brief window, cosmically speaking, where the universe is so active and dynamic.
Appreciate the intricate beauty, as the article put it, while we still can see it.
Exactly. There's value in understanding this transient life, our present existence, within this incredibly complex system.
And it sounds like this understanding is a big driver for organizations like NASA.
Oh, absolutely. Studying dark energy, the universe's expansion, its ultimate fate, its fundamental science. It demonstrates the sheer value of investigation, of pushing the boundaries of knowledge.
Trying to piece together the whole story, past, present, and future.
That's the core of it. Understanding these cosmic forces helps us build that narrative. It fuels exploration, satisfies that deep-seated human curiosity about the universe and our place within it, even if the potential end involves this barren, cold darkness.
Right. It still pushes us to learn more right now.
Definitely. The quest itself is valuable.
Okay, so wrapping this up, the main takeaway seems to be this big freeze scenario. Driven by dark energy, the universe keeps expanding, cooling, heading towards a future that's dark and incredibly cold.
That's the essence of the theory based on current understanding, yes. A universe fundamentally transformed by perpetual expansion and cooling.
And, for you listening, especially if you're a UPSC aspirant, grappling with these big ideas is actually quite relevant.
It really is. Concepts like the Big Freeze, dark energy, the evolution of the cosmos, they touch upon fundamental physics, cosmology, the nature of energy itself. Understanding these scientific frontiers is important context for many areas you study.
It stretches your thinking about systems, change over time, even the philosophy of existence, perhaps.
Absolutely. It connects to basic science principles, but also broader themes about evidence, theory, and our quest to understand the universe.
Definitely food for thought. So if this deep dive into the cosmic future got you thinking and you found it useful, maybe even for your UPSC prep, do give us a like, subscribe for more, and drop any questions you have in the comments.
We'd love to hear from you.
And remember, our main source for digging into the Big Freeze today was ecoticious.com, highlighting NASA's research. Thanks for joining us.